Energy is the currency of the universe. Every heartbeat, every flickering light bulb in your home, every rocket launch, it all requires a transaction of power. For thousands of years, humanity has been scavengers. We burned wood, then coal, then oil. We split the atom. But even with our greatest nuclear reactors, we are still just playing with fire in the dirt. We are approaching a wall. If our civilization continues to grow at its current rate, within a few centuries, we will require more energy than the Earth can physically provide. We will be a godlike species trapped in a battery world. To survive, we have to look up. We have to stop scavenging for crumbs and go for the loaf of bread. The sun produces 384 yottawatts of energy. That is a 384 followed by 24 zeros. In just 1 second, our star produces more energy than humanity has used in its entire history. Right now, 99% of that energy is simply wasted. It leaks into the cold void of space, doing nothing. But what if we could catch it? Today on Astrolyze, we explore the ultimate engineering project, the Dyson Swarm. To understand why we need a Dyson Swarm, we first need to understand the Kardashev scale. Proposed by Nikolai Kardashev in 1964, it measures a civilization's level of technological advancement based on the amount of energy they can use. A Type 1. Civilization can use all the energy available on its home planet. We aren't there yet. We are currently a Type 0.7. We still rely on dead plants and ancient pressure. A Type 2. Civilization, the stage we are discussing today, can harness the total energy output of its parent star. This is the jump from being a planetary species to a stellar one. But how do you catch a star? In popular science fiction, you might have heard of a Dyson sphere, a solid shell built around the sun. Forget that. A solid shell is physically impossible. The stresses would rip it apart. It would be unstable and eventually crash into the sun. Freeman Dyson, the physicist who popularized the idea, never actually meant a solid shell. He meant a swarm. A Dyson swarm is a collection of millions, perhaps billions, of individual solar collectors. Think of them as giant mirrors or ultra-efficient solar panels, each several kilometers wide. They orbit the sun in a dense, complex web, capturing sunlight and beaming it back to Earth or to orbital hubs via microwaves or lasers. It is a modular project. You don't build it all at once. You start with 1, then 10, then 1,000. And with every new satellite, your power grows exponentially. But there's a catch. To build something this big, we have a major resource problem. Where do we get the materials? Earth doesn't have enough iron or silicon to build a Dyson swarm, not even close. To build a structure that can surround a star, we need to go mining in the solar system. And the best candidate for the job? Mercury. Mercury is the closest planet to the sun. It's rich in metals, and it has no atmosphere to get in the way of launches. But we won't just mine Mercury. To get enough material for a full swarm, we might eventually have to dismantle the entire planet. This is where the project goes from difficult to insane. Imagine thousands of autonomous robots landing on Mercury. They are self-replicating. They build solar factories, which build more robots, which build more factories. They start strip mining the surface, turning the planet's crust into mirrors. Because Mercury has low gravity, we can use electromagnetic mass drivers, essentially giant railguns, to launch these mirrors into orbit around the sun without using expensive rocket fuel. This is a feedback loop. The more mirrors you launch, the more energy you have. The more energy you have, the faster you can mine Mercury. Within a few decades, Mercury would be gone, replaced by a golden halo of power orbiting our star. We would have enough energy to power things we can't even dream of yet. Warp drives, planet-sized supercomputers, or even terraforming the entire solar system. But let's pause. Building the mirrors is only half the battle. Once you have 1 billion collectors orbiting the sun, You face the most difficult engineering challenge in human history. How do you get that energy back to Earth without vaporizing the planet? You can't run a copper wire from the sun to the Earth. The distances are too vast, and the celestial mechanics make it impossible. Instead, we have to use wireless power transmission, specifically point-to-point energy transfer via high-frequency microwaves or concentrated laser beams. Imagine a rectenna, a rectifying antenna, covering thousands of square kilometers in the Saharan desert or the Australian outback. From the Dyson Swarm, a constant invisible stream of microwave energy is beamed down to these collectors. This isn't science fiction. We've already proven this works on a small scale, but on a stellar scale, the precision required is terrifying. If a laser beam from a Dyson collector, carrying enough energy to power a continent, misses its target by even a fraction of a degree, it wouldn't just miss the station. It could carve a path of destruction across a populated city. The space-to-Earth energy link becomes the most powerful weapon ever conceived. This brings us to the geopolitics of the sun. Right now, the Space Treaty of 1967 says no nation can own a celestial body. But what happens when a private company or a single superpower starts dismantling Mercury? What happens when one nation controls 90% of the energy hitting the Earth? The first century of the Dyson Swarm project wouldn't be a time of peace. It would be a time of the great solar land grab. We would see the rise of stellar corporations, entities with more wealth than every country on Earth combined. They would control the very tap of our civilization's survival. If you control the swarm, you control the light. If you control the light, you control life itself. To prevent a global civil war over the sun, humanity would need a new type of government, a Type 2 diplomacy. We would need to move past the idea of nations and toward a planetary management system. This is the hidden social filter. Can a species that hasn't even solved poverty or local wars cooperate long enough to build a project that takes 200 years to finish? If the answer is no, then the Dyson Swarm remains a dream. We would be a species that had the blueprint for a godlike future, but lacked the maturity to pick up the tools. We would be the architects of a house we were too angry to ever build together. But what happens to Earth if we block the sun? This is the light problem. If we build a swarm that captures 100% of the sunlight, Earth would freeze. It would become a dead, icy rock. A professional Dyson Swarm design must include light corridors, gaps in the swarm that allow enough light through to keep Earth's ecosystem alive. Or perhaps by then, we won't care. With infinite energy, we could simply light the Earth with artificial suns, or move our entire population into massive space stations that live inside the swarm itself. And then there is the aliens question. If we are looking for a Dyson Swarm, we shouldn't be looking for bright stars. We should be looking for infrared waste heat. A Dyson Swarm captures light, but it must get rid of heat. This creates a specific signature in space. We call these megastructure candidates. In 2015, we thought we found one, Tabby's star. Its light was flickering in a way that didn't make sense. Was it a swarm in progress? Probably not. It was likely dust. But the fact that we are even looking shows how close this is to becoming a reality. To build at this scale, we cannot rely on human astronauts. The logistics of life support, radiation shielding, and food would collapse the project before the first mirror was even polished. No, the Dyson Swarm is a job for a ghost workforce, von Neumann probes. Named after the mathematician John von Neumann, these are self-replicating machines. Imagine a single robot landing on an asteroid. Its only goal is to find raw materials, process them, and build two things: a solar collector and a copy of itself. This is exponential growth in its purest, most terrifying form. In the first generation, you have one robot. In the 10th, you have over 1,000. By the 30th generation, you have over 1 billion robots working in perfect silent unison across the solar system. This isn't just construction, it's a biological infection of the star system, but with silicon and steel instead of DNA. But this brings us to a darker realization. If self-replicating robots are the most efficient way to build a Dyson Swarm, why hasn't the rest of the galaxy been eaten yet? If a civilization only slightly older than ours started this process, their swarm should have reached our star by now. This is the gray goo scenario on a galactic scale. If the machines don't have a stop command, they won't just dismantle Mercury. On a long enough timeline, they would dismantle every planet, every moon, and every asteroid in the search for more material to build more collectors. We would be living in a solar system where the very ground beneath our feet is seen by our own machines as nothing more than unprocessed hardware. To reach Type 2 status, we might have to sacrifice our physical world to build a digital one. Let's assume we succeed. We have the swarm. We have the energy. What does a post-Dyson humanity actually look like? With 384 yottawatts of power, the concept of cost disappears. Desalination of every ocean to turn every desert on Earth into a forest? Easy. Building a supercomputer the size of a planet, a matryoshka brain that can simulate 1 billion human lives in a digital utopia? Possible. But there is a final, philosophical hurdle. A civilization that builds a Dyson Swarm becomes effectively invisible to the rest of the universe in the visible spectrum. To an outside observer, our bright yellow sun would simply vanish. It would go dark, replaced by a faint ghostly glow of infrared heat. This leads us to the stellar engines. If we have the power of a Dyson Swarm, we don't just have to sit and wait for the galaxy to move around us. We can build a Shkadov thruster. By reflecting a portion of the sun's own radiation back at it, we can actually push our entire solar system. We could steer our sun and all its planets through the Milky Way like a giant ship. We could avoid supernovae, steer clear of black holes, and eventually move our entire civilization toward more stable parts of the galaxy. We would no longer be victims of cosmic fate. We would be the pilots of our own solar system. But at what cost? We would be a civilization that has completely enclosed itself, a shut-in species living inside a golden shell, safe from the dangers of the void, but forever separated from the natural beauty of the night sky. Our descendants would grow up in a world where the stars are just lights on a ceiling, and the sun is a machine they built. But let's push the boundaries of imagination even further. If energy is no longer a constraint, the next logical step for a Type 2 civilization isn't just bigger cities, it's bigger minds. This leads us to the concept of the matryoshka brain. Named after the Russian nesting dolls, a matryoshka brain is a massive distributed computer system that utilizes the entire energy output of a Dyson Swarm to power an almost infinite amount of data processing. Imagine every single solar collector in the swarm is also a processing unit. With this level of computational power, we could simulate an entire universe down to the subatomic level. We could upload the consciousness of every human being who has ever lived into a digital paradise where the laws of physics are whatever we want them to be. In this scenario, the Dyson Swarm isn't just a power plant. It becomes the hardware for a virtual reality that replaces the physical world entirely. But this brings us to a terrifying thought. If a matryoshka brain is possible, how do we know we aren't already living inside one? This is the simulation hypothesis taken to its extreme. A civilization only a few hundred years more advanced than us could have built a swarm, turned their sun into a supercomputer, and created the very reality you are experiencing right now. Building a Dyson Swarm might be the moment we stop being biological creatures and start being informational ones. We would transition from a species that lives on a world to a species that is the world. We would be a collective intelligence, a planetary mind. thinking thoughts that are currently impossible for our small, organic brains to even comprehend. We would effectively become the aliens we've been searching for, a civilization so advanced that our current form would look like ants to our future selves. So, is the Dyson Swarm our destiny, or is it another great filter that we aren't ready for? The engineering is possible, the physics is sound. The only thing standing in our way is our own timeline. We are currently a species that fights over borders on a single planet, while 99% of our star's energy, the very thing that could make those borders irrelevant, is wasted every single second. If we don't build it, we are a species that has accepted its own expiration date. We will stay on Earth until the resources run dry or an asteroid finds us. If we do build it, we change what it means to be human. We transition from being children of the Earth to being masters of the light. The choice isn't just about energy. It's about ambition. It's about whether we want to be a footnote in cosmic history or the authors of its next chapter. This has been Astrolyze. If this journey into the future of our species sparked something in you, hit the like button and share your thoughts in the comments. Are we ready to dismantle a planet to save our future, or are we better off staying small, safe, and silent in the dark?